We are now going to look at 7.1 Part 2 notes, and notice that I have on the first page of these notes that you are going to need a ruler, so make sure you have a straight edge or a ruler handy as you are filling these notes out. So we're going to look at today, last time in 7.1 we found the solutions of systems by graphing. And today we're going to look at what happens when they don't intersect in a point, and rather one of our solutions is no solution. And so the thing to point out here is when two lines are parallel, remember if they're parallel, they have the same slope and they are never going to intersect each other. And so since they do not intersect, there will not be a solution that's an ordered pair, and our solution now will be no solution. The same, or I guess another option that could happen is if we have a system of linear equations where the solution is now this infinitely many solutions. And this is when the graphs of the equations are the same line. So this is going to happen when your slopes are the same, and so it can't just be slopes. Your y-intercepts are also the same. So when your slopes are the same and your y-intercepts are the same, you're going to be graphing the same line on top of the other line, and your solution will be infinitely many because they are touching in every single spot. But not to be confused with when you're going to put no solution, you need to remember for no solution, your lines are parallel. Let me erase this here. But the slopes are the same. But the difference is, notice this y-intercept is down here at -4, it looks like, or -3. And then this y-intercept is up here. So when your lines are parallel, they will have the same slope, but they will not have the same y-intercepts. So same slope, different y-intercepts for your parallel lines. So let's move on and look at some examples of this. And here, this is just a chart showing you what this looks like. So this is what we did on the first part of 7.1. Your lines all intersected at a point, and you wrote that ordered pair as your solution. Today we're going to look at when lines are parallel. Again, the answer is no solution. And if I graph the same line on top of the other line, my answer is infinitely many solutions. So without graphing, we're going to decide whether each system has one solution, no solution, or infinitely many. So remember, if the lines are parallel, they're going to have the same slope, which if you notice, those both have a slope of 2. And then the question is, are they the exact same line? So do they have the same y-intercept here? Well, the y-intercept here is missing, so that means it's 0. And the y-intercept here is -5. So those are going to start at different points, but they are going to slope the same way because they have the same slope. So these are examples of lines that are parallel to one another, and we know that parallel lines never touch, and so we know that the answer, the solution, is no solution. Okay, now let's look at the second example. Now, if you'll notice on this second example here, these are not in slope-intercept form. These are in standard form. So we cannot know the slope just by looking without doing any work. So we need to get this into slope-intercept form, which we're going to do by solving for y. So we're going to subtract x on both sides, and that's going to give us y equals, and then I'm going to write that as -x plus 4. And that's a -1 in front of that x. And then I'm going to do the same thing for the second equation. I need to get it in slope-intercept. So I'm going to solve for y. So I'm going to move that 2x to the other side first. And I have 2y equals -2x plus 8. And I'm not quite done because I need to solve for y. So that means I need to divide everything by 2. And so that's going to give me y equals -2 divided by 2 would be -1x. And then 8 divided by 2 is 4. So if you'll notice this time, these lines have the same slope. Both the slopes are -1, and they have the same y-intercept. So these are actually the exact same line. So if you're graphing the exact same line on top of itself, then we know the answer is infinitely many solutions. Infinitely many solutions because they're touching all the points at the same time. Okay, so looking at the next example, if you'll notice this first line is already in slope-intercept form, so I can tell that its slope is -3, and the y-intercept here is +1. So if we look at this second line, this is not in slope-intercept form, so I need to solve it for y. So I'm going to add 3x to both sides, and then that's going to give me y equals 3x plus 7. So this line has a slope of +3. So if you're looking at this one has a slope of -3, this one has a slope of +3. Are those the same? No, because we know that that means one of them is going downhill and one of them is going uphill. So we can automatically stop because if the slopes are not the same, it cannot be no solution because they're not parallel, and it cannot be infinitely many because they're not the exact same line. And so the answer to this one would be what you would have gotten out yesterday, and it would give you an ordered pair if we actually graphed it, which is one solution. Okay, lastly, I need to determine these two equations, and neither of these are solved for y. I'm going to do this one down here, do the work here. So I need to solve this for y, so I'm going to subtract 3x on both sides. And then I'm bringing down negative, don't forget your negative there, -5y equals -3x. And then I'm going to divide by -5 on both sides. So this gives me y equals negative over negative is a +3/5x. And then I'm going to do the same thing on this second line. All I have to do now to solve for y is just divide by 5. So I have y equals 3/5x. And so if you'll notice, these are the exact same equation, which means they're the exact same line. And so if I'm graphing the exact same line on top of the other line, I know that my solution is infinitely many solutions. Okay? And that's how we can find the solutions if we're not looking at a graph. Now we're going to move on to what it looks like when we have a graph. So let me erase this. So we're going to graph this system, tell whether it has no solution, infinitely many, and those are going to be the only options today, no solution or infinitely many. Now, when these equations that we are giving you, if they are in standard form, you have the option to either find your x and y intercepts, or you can put them in slope-intercept form by solving each one of these for y. I'm going to put them in slope-intercept form because I find that that's what most of you tend to do. So we're going to go that route. So I'm going to do my work down here. So I'm going to take this equation and I'm going to solve it for y. So first thing I'm going to do is subtract 3x on both sides. That's going to give me 6y equals, and then I have my -3x and then a +12. And then I'm going to divide by 6 everywhere. So y equals, and -3/6, that reduces, if I divide by 3, top and bottom, to -1/2x. So slope is -1/2, plus 12/6 is 2. Okay? And then I'm going to do the same thing to my second one. So before I graph that, I want to see what these look like here. And we're going to solve again for y. So we're going to subtract 2x on both sides. So I have 4y equals -2x plus 12. And then I'm going to divide by 4 everywhere. So I have y equals -2 divided by 4. I can reduce those top and bottom by 2. So that's -1/2x plus 3. So before I even graph this, you're always checking the slopes. So here are the slopes. Notice the slopes are the same. The second thing I want to check though are the y-intercepts. Are the y-intercepts the same? No, they start in different spots. So what we should know is that these lines should be parallel. So I'm going to graph this blue line first. You're going to graph the y-intercept first at +2 on the y-axis. And then we're graphing a slope of -1/2. So we're going to go down 1 and right 2, or I could go up 1 and left 2. And then you're going to take your ruler and you're going to connect those points so that you are making a straight line. And I don't know if I have a line tool. So I'll just do mine the best that I can here. Ooh, not great. Okay, so there's my blue line. And then next I'm going to do my red line. My red line starts at +3, so it's going to be close to it, but they're not the exact same. And I'm going to do the same thing, down 1 and right 2, or up 1 and left 2. So if you notice, these lines are very close, but they are never going to touch because they are parallel to each other. And hopefully your lines look a little bit better than mine. And so because we know from the beginning, because we knew their slopes were the same, but they started in different spots, we knew that these lines were never going to touch, and our answer was no solution. Looking at the next example, we're going to do the same thing here. We're going to go ahead and put these in slope-intercept form. So I'm going to start with this one. I'm going to start here because this one's pretty simple. All I have to do to solve for y is subtract this 4 over to the other side. So I have y equals 3x minus 4. So there's my first equation. And then I'm going to do this second equation. So this time my y is over here on the right side of the equation. So I'm going to take this 12x, I'm going to move it over, and I'm going to do that by subtracting 12x to both sides. So I have -12x, that's a +16 equals, that's a -4y. And then we're going to divide everything by -4. So then I have -12 divided by -4 is +3x. 16 divided by -4 is -4 equals y. And then I'm just going to rewrite that with my y in front. So y equals 3x minus 4. So if you look at these two lines that we got, notice they are identical. They are the exact same. So we're going to graph them, one on top of the other, which basically just make your line bold. So we're going to start with the y-intercept, which is down 4 on the y-axis, and put a point. And then we're going to graph a slope of 3 over 1. So we're going to go up 3 and right 1, or down 3 and left 1. I'm going to do that one more time. 1, 2, 3, and over 1. And then you're going to take your ruler and you're going to connect your points. And if you want to make it extra dark just to show that it's the same line on top of each other, that is great. Mine's getting a little sloppy here. And so we know when you have a line on top of itself that the solution is infinitely many solutions. I'm going to abbreviate solutions, SOL. And so that's what it looks like when it's infinitely many. Next one, again, we're going to solve this for y. And notice that this first one already has y by itself. And so I'm just going to rewrite it with the y in front because that's how we write slope-intercept form. So I'm going to just rewrite it. Y equals 2x plus 6. Okay, now on the second equation, again, I'm trying to get y alone. And what else is over there with that y is that plus 8. So I'm going to subtract 8 on both sides. So I have negative 4x minus 8 equals, and that's a negative 2y. And then I'm going to divide by negative 2 everywhere. Negative 4 divided by negative 2 is 2x. Negative 8 divided by negative 2 is positive 4 equals y. And then I'm just going to rewrite that again with y in front. So y equals 2x plus 4. So if you'll notice this time, what's the same? The slopes are the same. Do they start in the same spot? This one starts at 6 and this one starts at 4. And so those are not the same. So we're going to graph those separately, which means they slope the same, but they start in different spots. These should be parallel. So we're going to start with the blue line up here, y equals 2x plus 6. We're going to put our y-intercept at 6 on the y-axis, and then we're going to go up 2 and right 1, or down 2 and left 1. And I'm just going to draw a couple more points so my graph is a little more accurate. And then you can graph your line. And then I'm going to do my green line. And this one's starting at positive 4. We're going to do the same thing, go up 2 and right 1, or down 2 and left 1. I'm just drawing a couple more points in. And notice these lines are sloping the same, but they are never going to touch. I realize that mine are pretty sloppy. Hopefully you're using a ruler and yours don't look like this. And so we know that the answer for parallel lines is no solution. Okay, that concludes our notes for 7.1 Part 2. Thanks for watching.